Hey everyone, today I'm going to be walking you through deriving the Michaelis-Menten equation. Up top here, before we start, I just wrote out some general kind of terms that we'll need to know throughout this process. E is for enzyme, S we're talking about substrate, P is the product, K1 talking about the forward reaction of part 1, K-1 talking about the backward reaction, K2 we're talking about the forward reaction of part 2, VO equals velocity, Kcat is going to be the number of molecules an enzyme can work with per second, also known as K2. The Vmax is going to be our maximum rate, D is the instantaneous rate of change, and Km is the Michaelis constant. And obviously throughout this process, I'll be referring to these, but this is just so we can kind of remember everything here. Okay, step 1. We are going to write out the two equations that we'll need to start this. So first we will have the enzyme plus the substrate is equal to the ES, which is the enzyme substrate complex. With this, like I said up here, we know that K1 is the forward reaction of step 1 here, so we can label this K1, and we know that K-1 is the backwards reaction, so we can label this K-1. Then down here in step 2, we know that the enzyme substrate complex yields the enzyme plus a product. So with this here, like I mentioned earlier, K2 is the forward reaction of step 2, so we can label this K2. All right, so starting with these two equations, we will determine the value of E, which is the unbounded enzyme. We are going to use the K1, K-1, and K2 throughout this process. And we know that the enzyme substrate complex is equal to the sum of all the reactions decreasing its concentration, which ultimately will equal 0. So with this knowledge, we can kind of work our way through to come up and solve for that enzyme there. So starting on step 3 here. Knowing these two equations, we can kind of rewrite this. So we know that the instantaneous rate of change for the enzyme substrate complex over the total instantaneous rate of change is equal to 0, which is basically what I just said earlier with the K1, the K-1, and K2 all ending up to equal 0. And then this, with this all written out, looks like K1 times the enzyme substrate minus K-1 and this looks long and confusing, but all it's really saying, each one of these in here is just the reactants for each one of these reactions. So E plus S are the reactants for K1, ES is the reactant for K-1, and ES is the reactant for K2. So down to step 4 here. Like I said earlier, we are trying to solve for E. So we're going to do this by saying that the total amount of E, or E sub T, is equal to E plus ES. Okay, and then we want to kind of get we want to get ES, or we want to get E by itself to solve for, so we can rewrite this by saying E is equal to E sub T minus ES. Okay, and we are going to use this for later in our next step. Let me just get on my piece here. Okay, so step 5. Now we're going to substitute in our new value for E back into that original equation. So it's going to look like this. K1 times E sub T minus ES times S minus K negative 1 times ES minus K2 times ES. Okay, now we're going to distribute K1 throughout. So we will have negative 1 oh, I'm sorry, this is K1. Okay, so now that we've distributed K1 throughout, we are going to move all the terms with ES to one side and then factor it out. So it's going to look like ES So now that we have ES factored out, we are going to divide both sides by K1 times S plus K negative 1 plus K2 so that we can get ES by itself. So that will look like this. E sub T S divided by K2. Okay, so now we can get rid of K1 since it's in the numerator and denominator. So we're just going to multiply this by 1 over K1, and that is going to give us ES equals E sub T times S divided by S plus K negative 1 plus K2 divided by K1. Okay, so this here is done from that first step 1 where we had the E plus S yields the enzyme substrate complex, sorry. So now we're going to use the second equation that we have, which was the enzyme substrate complex yields the enzyme plus the product, to get the second part of this equation. So with that being said, we have the instantaneous rate of change for the product is equal to K2 times ES. So we got this because, just a little reminder here, that second equation was ES yields E plus P, and this was K2. So we have the K2 there, and then we just always times the K2 by the reactants, and so this case, ES was the reactant there. Okay, so now since we just solved for ES above, we're going to plug in this equation in for ES here. So that will look like this. dP. Now, before I continue writing, this here is actually equal to Km, and Km is known as Michaelis constant. So instead of writing all of this out, I'm going to substitute Km down here in this equation. Okay, so now we have this equation here. So next we're going to think in terms of velocity, okay? So let me get a clean sheet of paper here. So with this here, we know that velocity is equal to the instantaneous rate of change of the product over the total amount of instantaneous rate of change. All right, and as we remember up here, dP is equal to this equation here. So we're going to write this as K2 T plus S for S plus Km. Now, if you remember way back to the beginning, I said that K2 can also be written as Kcat, which is pretty much the same thing there. So you can then write this as Kcat times ET plus S over S plus the Km. Okay. So now that we've substituted that in, we can think, if you think of what this means, Kcat plus or times ET. This means that it's the total concentration of the enzyme, which is ET, the total enzyme concentration, times, as we said earlier, the Kcat is equal to the total number of molecules an enzyme can catalyze per second. So this together means that all of the enzymes that are available are reacting with the most molecules possible, which would give us the maximum rate. So maximum rate is equal to Vmax. So we can substitute in Vmax for this here. So then this new equation can be written as VO equals Vmax times the substrate over the substrate plus Km. Or I'm sorry, times Km. All right, so this here is the final Michaelis-Menten equation. Velocity equals Vmax times substrate divided by the substrate times Km. And when you think of Km represents the concentration of the substrate when the reaction rate is half of the Vmax. So like we said earlier, the Vmax is the maximum rate at which all the enzymes are reacting with the molecules. So in order to kind of understand how this equals half Vmax, if you think of Km equal to the amount of substrate that's available, and you just kind of rewrite it like Vmax times the substrate, and then the substrate, and we're pretending that the amount of Km is equal to the amount of substrate. This then becomes Vmax times the substrate over 2S. The S's will cancel out, and then you will just have Vmax divided by 2, which is how we get the value for Km here. So thanks for watching my video on explaining the Michaelis-Menten equation.
And hopefully I made it a little simpler for everybody to understand. Thank you.